Hello everyone, let's continue our tutorial on internal energy. As we said in the previous video, the internal energy of an object is related to its temperature and to its specific heat capacity. We can refer to this idea as an equation, where delta E, which is the change in internal energy, equals to the mass times the specific heat capacity of a substance times the change in temperature, where the triangle called delta means change. And theta sign here means temperature, so delta theta is the temperature change of the substance while cooling or heating. To see how this works, let's solve an example. Find the final temperature of 800 grams of water at an internal temperature of 20 degrees after 20 kilograms of energy has been transferred to it. As we know, the specific heat capacity of water is 4,200 joules per kilograms per degrees Celsius. Note that specific heat capacity of a given substance is constant. In order to find the final temperature, we first calculate the change in temperature, so we need to divide both sides of the equation by the mass times specific heat capacity. This ratio equals to the change in temperature. Next, we make sure all of our units are correct. So we change 800 grams to 0.8 kilograms by dividing this value by 1000. And we change 20 kilograms to 20,000 joules by multiplying this value by 1000. Then put these values into the equation. So delta theta, which is the change in temperature, will be equals to 5.95 degrees. As final temperature equals starting temperature plus change in temperature, we have to calculate, so we add this value to our original 20 degrees. The final temperature would be 25.95 or 26 if we round it to the three significant figures, which should be done in the exam. Now, one thing to point out is that in real life, the temperature probably wouldn't increase as much because some of the energy would be lost to the surroundings.